Welcome to another video from explainingcomputers.com. This time I'm going to talk about solid-state disks, otherwise known as SSDs. Today, most SSDs come in the form of memory cards or USB keys. However, over the next few years, we're increasingly going to see SSDs used as replacements for traditional hard disks. Already, many netbooks and tablets use a solid-state disk in the form of a PCI Express or SSX card. For some time, adapters have also allowed compact flash cards to replace or supplement a traditional hard disk. However, there are now an increasing number of SSDs being manufactured as direct replacements for traditional hard disks. Most commonly, these are the same size as a 2.5-inch hard drive and connect via a standard SATA interface. To understand the potential benefits of SSDs, it is best to compare them with traditional hard drives. Inside a conventional hard disk, there are spinning magnetic platters on which data is stored. A tiny head at the end of an actuator arm moves about to read and write data to different areas of the disk. This design has served us well for decades. However, it also consumes a fair amount of power and is not always as fast as we would like. The platter and mechanical mechanisms are also somewhat fragile and easily damaged. In contrast, a solid-state disk has no moving components. Indeed, if we look inside, we find only a circuit board containing the flash memory chips on which data is stored. This means that solid-state disks use less power than traditional hard drives and are far more robust. Because an actuator arm is not having to chase across a spinning disk, SSDs can also access all data extremely quickly. By replacing a PC's hard drive with an SSD, it is possible to obtain significant performance improvements. For a start, the computer never has to wait for the drive to spin up. Fast, random access to data is also always available. Energy is also saved, with most SSDs using well under 2 watts, compared to the 10 to 20 watts used by some traditional hard drives. Replacing the hard drive in a laptop with an SSD also makes it far more robust. Finally, SSDs are entirely silent. SSDs do, however, have their disadvantages. For a start, the cost per gigabyte is far higher than traditional hard drives. Drive capacities are also significantly lower. Whilst reading data from an SSD is blindingly fast, data is written far less quickly and sometimes barely faster than a traditional hard disk. All SSDs also run a process called wear leveling to ensure that no single block of flash memory is used too intensively. Whilst preventing premature drive failure, this can lead to the performance of an SSD decreasing over time. Wear leveling can also cause problems with data encryption techniques. SSDs come in 2 technology variants known as single-level cell or SLC and multi-level cell or MLC. Single-level cell SSDs store 1 bit of data in each flash memory cell. In contrast, multi-level cell SSDs use each cell to store 2 or more bits of data. This makes multi-level cell SSDs significantly cheaper. However, it also makes them slower as data is more difficult to access. If an SSD is being fitted to a PC purely to achieve performance improvement, it is therefore better to opt for a single-level cell device, even if this means buying a disk with a smaller capacity. The price of solid-state disks is now falling to a point where people with a particular need for very high-speed, robust, quiet or energy-efficient computers are starting to fit them as system disks. As prices fall further and as more and more of us store most of our data out in the cloud, so increasingly more people will be using a computer without a traditional spinning hard disk. For more information, please see the storage section of explainingcomputers.com. But for now, that's it for another video, and I hope to talk to you again very soon.